Hi all, my name is Sai Dinesh Kuripati. Today we are gonna discuss about cross-language program slicing for dynamic web application. Now I am saying about the abstract of the paper. During the software maintenance, program slicing is useful technique to assist developers in understanding the impact of their changes. While different programming slicing techniques have been proposed for traditional software systems, the program slicing for web programming applications is challenging since the client-side code is generated from server-side code and data entities are referenced across the different languages are often embedded in string literals in server-side program. We identify the data flow dependencies among data entities for PHP code based on symbolic execution. We also perform SQL queries and a conditional DOM that represents the client code variations and construct the data flows for embedded language such as SQL, HTML, and JavaScript. While we are discussing about these, the main keywords are program slicing, dynamic web application, and cross-language analysis. Now we are going to discuss about the introduction. Program slicing is an important and useful technique in several software engineering applications. For example, it is like a useful tool to assist the developers in understanding the impact of their changes for activities such as programming or bug fixing. While various program slicing techniques has been developed for traditional software programs, program slicing for web applications is challenging due to the dynamic nature. The server-side code often used in PHP, ASP, GSP, etc. dynamically generates HTML pages on our input and data retrieved from databases. While a program slicing technique would need to identify those embedded entities and recognize the data flow among them. Finally, the data flows from the embedded code might be governed by the conditions of the server-side code. Next one. In this paper, we present the web slice technique to compute the program slices for dynamic multilingual web applications. We compute a program slice based on data flow among the entities. We analyze the SQL queries and the random construct the data flows for each language of the embedded code for SQL, HTML, and JS. During this process, the multilingual nature and the dynamic generation of the client code is dynamic web applications raise challenges for program slicing. First, web applications are written in multiple languages that including server-side languages, PHPs, and SQL. We derive the program slice first by including all definitions and references that have to direct or indirect flow relations with C possible across different languages. As we mentioned before, there are three main important key points we need to remember. First one is an algorithm to build data flow relations among data entities for server-side PHP and embedded code via symbolic execution. Next one is an approach combining the symbolic execution, variability, aware parsing, and data flow analysis on embedded code to compute cross-language program slices for dynamic applications. And the next one is an empirical study to investigate the complexity of data flows and program slicing in PHP web applications. These three are the key points, and also these can be used in the further paper. Now my friend is going to explain the rest of the topic. Thank you.
Hi, I am Raviteja. Today I am going to explain about motivating examples for cross-language program slicing for dynamic web applications. To show the challenges in computing program slices for PHP web applications, we use a running code example adapted from an open source web application for managing a school information. In this, we have two pages, manage announcement.php and edit announcement.php. In the manage announcement.php, We display all announcements. We display all announcements in the database and allow say users to select one of them for editing. Where after selecting the announcement, the user is redirected to edit announcement.php to update the details of an announcement. From there, the updated information is sent back to the first page, which updates the database of announcements with the new details. In this process, the data of the announcement is propagated across two stages. One is server side and a client side. The different pages and multiple languages like PHP, HTML, SQL, as exemplified by the edges. Identifying such program slices is useful in a number of applications, such as debugging and change impact in a number of applications. Uh, the Although desirable program slices for dynamic web applications faces a number of challenges, we do have um, cross-language data flows. First, data entities can have relations across different languages with the different pages. That is, the value of data entity computed in one language may affect the value of another entity in another language. Like in addition, to a data entity appearing in the execution of one page may refer to the value of another data entity appearing in previous execution of another page. For example, the PHP variable post update refers to the value of the HTML updated generated from a prior execution of another page. Uh, the second one is embedded entities. In a web application, there are different types of program entities written in multiple languages. Now, program sizing analysis. We are interested in program entities that contain data such as PHP, JavaScript, variables, and HTML forms and inputs. We can call them as data entities. Such entities appears in a program as definitions and references. A definition of an entity is the code location where the entity is declared or assigned with a value. A reference to an entity is the code location where the entity is referred via the entity's name. Since the client side code is dynamically generated from the server side code, data entities can be embedded in PHP strings. That is, definitions reference of an entity might be embedded with PHP strings, literals. Example, the HTML input updates the concatenated form to PHP strings and PHP variables. HTML fragments from string literals can be printed directly with the echo print statements, but can also be assigned to PHP variables propagated through computations and printed out later. Um, the relations between embedded entities could cross strings literals and requires an analysis on the semantics of embedded code. The last one is like conditional client code. The data flows for embedded code might be determined by conditions in the server side code. That is, some of the dependencies are conditional. For instance, if HTML forms are generated for different types of users, uh, members or guests, the data flows on a program slices for the entities in these forms are dependent and on the conditions in the PHP code for those user types. And now my friend will continue the web application slicing.
Hi, my name is Nitish. I'm going to explain about web application slicing. So, a forward program slice consists of parts of a program that may be affected by the values computed at a slicing criteria, which is a point of interest typically specified by a program point and a set of variables. Various program slicing methods have been proposed since different properties of slices might be required for different applications. In this paper, they have chosen a class of program slicing that is based on data dependencies. This class is called thin slicing, as opposed to traditional slicing based on both data and control dependencies, which typically produces slices that are too large to be useful for human inspection. A full slice can always be easily expanded from a thin slice. So the next step is approach overview. From this there are 4 steps. The first and second step are with one language, and third and fourth step are across languages. So here I am going to explain about extension of data flow relations for dynamic web applications. From step 1 we can see that from a PHP page, a symbolic execution for data flow analysis will be created. From there the output with symbolic values will be sent to parsing, and the next step is we can do that by using conditional data object model, that is by using variables. And the next step is we can analyze the HTML and synchronize the execution on JavaScript, and from there we can see the data flows for HTML and data flows for JavaScript. There you can see connecting data flows, and these data flows for HTML and JavaScript can be sent to the connecting data flows. Step 1 and step 2 are connected because we are testing with across languages, and these connecting data flows are then sent to cross language data flows. From there we can use slicing criteria. By computing slice we can get the program slice for C. I'm going to explain in detail about extension of data flow relations for dynamic web applications. So here there are 2 types. One is diffuse and second one is info use. The diffuse means definition use, and the info flow means information flow. So the first and second steps are with one language, and third and fourth steps are with across the languages. So from step 1 we can see that there is a definition D and reference R of a variable. We have a def use relation, that means they both use definition use relation. And the second one is ref to def, that means there is a reference flow information from 1 to 2. In step 3 there is a use of relation diffuse, that is definition use, that is going to take a reference R and a definition D have a cross language relation if R and D are written in different languages. So for instance, the PHP variable post, that means updating variable, refers to the value of an HTML input named update. So in the step 4 in across languages we have to use info flow, that means information flow. A reference R in language L1 and a definition D in a different language L2 have cross language information flow relation if R generates R. So example, in PHP code echo input name input 1, the value of PHP variable is assigned to the value of HTML input in input 1. The next I'm going to explain about types of data flow relations. So we discuss this expansion. Specifically, we define a forward thin program slice with respect to slicing criteria C specified by the code location of data entity. A set of definitions and references of data entities in the web application that have direct or indirect data flow relations from the value computed at C. For instance, the program slice for the SQL data entity includes all the data entities along the edges. So we propose a program slicing technique for dynamic web applications that is based on the relations between definitions and references of data entities, namely definition use, that means diffuse relations, and information flow, that is inflow flow relation, which are traditionally used for analyzing programs written in single language. In the context of dynamic web applications, we extend these relations also for entities that are written in different languages.
Today, I am Kranti to present about web slice. Web slice is an approach to compute program slices in a PHP web application. It follows four main steps. Performing symbolic execution on the PHP code to approximate its output, as well as constructing data flows for server-side code in PHP and SQL. Parsing and analyzing the output to construct the data flows for client-side code in HTML and JavaScript. Connecting data flow across different languages, and computing a slice given a slice criteria. The code is written in assembly language to approximate the output of a PHP program so that it can be translated into machine code. In this code example, we use our symbolic execution engine to construct the data flows within the server-side code. The result of symbolic execution is a generated client-side code which possibly contains symbolic values and values that are produced under specific path constraints. For illustration, the output of the code in figure below is shown with Greek letters for symbols and hashtag if directives representing texts that are output under some constraints. Symbolic execution explores different paths in the PHP program and computes or propagates the values of definitions and references of data entities. We use a new mechanism to record data flows within PHP as well as within the underlying database. In addition, an advantage of using symbolic execution is that we can eliminate some infeasible flows. For example, in the code below, the PHP variable we studied does not have required relations since they are under different path constraints. For scalability, we have made several approximations to our symbolic executor, such as running at most 2 iterations of a loop and skipping recursive function calls. Also, symbolic execution allows us to resolve dynamically included PHP files, thereby detecting data flows that would otherwise be missed. Embedded code analysis. To detect flows within embedded client code, we first pass the output produced from the previous step with our HTML and JavaScript variability-aware parsers. The software is based on the type-chef variability-aware parsers framework, which enables programs with conditional parts to be written in different languages. The result is a bar-down representation of the embedded client code, which represents the hierarchical DOM structure of a web page. Note that variability-aware parsing is sound and complete with respect to brute force parsing of all possible variants, but much faster. Unlike an HTML DOM, a bar DOM contains condition nodes to indicate that certain web page parts can be produced under certain path constraints. A bar DOM is a DOM tree that contains all possible generated client pages with symbolic values in a single tree structure. The var DOM also contains conditional ASTs for JavaScript code with conditional and symbolic parts. In this way, the var DOM represents all possible paths to and from a page in a web browser. For example, the HTML input field update has a type attribute under which its value attribute has a symbolic value $ID with a range from 0 to 100. We are able to analyze the code written in HTML or JavaScript and build their respective data flows. Since HTML is a declarative language, we collect the definitions of HTML entities. For JavaScript code, we compute its data flows using a lightweight symbolic execution engine with an algorithm. Connecting data flows. Data flows can exist among data entities of different languages and across different pages. We connect the data flows among those entities based on cross-language diffuse and information flow relations. For instance, the input fields in the HTML form have cross-language diffuse relations. The corresponding PHP $get or $post variables on page edit announcements, and the inputs fields are submitted. Through this step, we obtain the data flows for the entire web application. From the below figure, it shows the data flow graph for our example, in which the nodes represent the definitions or references of entities, and the edges represent direct data flow relations. Computing slice. Using this technique, we can produce a data flow graph that allows us to quickly compute any program slice for a given programming language. The program slice is a set of definitions and references that are reachable from C in the graph, rather than just definition or reference.
Hi, this is Badri. Yes, my teammates completed till fourth part. I'm going to start with fifth one, which is data flow analysis. This section presents our algorithm to construct the data flow and to compute the output and SQL queries of PHP code. The algorithm is built on top of our symbolic execution engine. We first introduce the notation that will be used to describe our technique. So coming up to the next part, notation. In this, we can see V and C symbols, which is C is the set of all values, including the symbolic ones. So, and then C is the set of all control codes that represents the return values of statements. Example, return or break. And also S, E, and then N are the set of all statements, expressions, and identifiers respectively. Pi is the set of all path constraints. Each constraint is a proportional formula. L is the set of all definitions and reference. We use small letters for elements of a set. Our symbolic execution engine processes a PHP program and consider all unknown values such as user input and data from a database as symbolic values. When reaching a control predicate, it explores feasible paths and keeps track of the path constraint for each path. Specifically, we maintain a program state where the value store V is to n follows V is a total function mapping a variable name to its value. The path constraint encodes the branch decisions taken to reach the current state. So coming up to the execution part, we see the first one is initialization. Initialization parts and coming up, they explained all those in 14 steps, like variable accesses, assignment, if statement, and then coming to the function declaration, function invocation, return statement, block of statements, and then eighth one, while statement, include expressions, infix expression, echo statement, MySQL query, and then last but one, MySQL fetch array, and then finally array access of SQL data. So after this one, all the execution part, we will see that notation and auxiliary functions, which is in this part we get to know all the expressions, what is what, and they explained each and every letter which defines what is that. So we can see that the arrow mark denotes total function, z denotes that f of x goes to the y denotes a function same as f, except that g of x equal to y. So finally coming to the figure 6, you can see that figure 6 is at here, detecting data flows at conditional statements. We can see that statement, all the statements in this figure. So coming up to this, our symbolic executor evaluates statements in a PHP page and repeats this process for other pages to build the data flows of the entire web publication. From the figure 5, shows the key evaluation rules for a statement as a rule denotes that the execution of yes changes the program statement of the returned value. C is a control code. It returns OK. If there was no control flow breaking instruction in S, statement cannot be executed. So the next sequential statement can be executed. And the other control codes, otherwise for an expression E, a rule denotes that the evaluation of E results in new program statement of returned values. So in figure 5, we formalize the rules for our previous execution engine and highlight the parts that we extend to identify data flow relations. Identity and add relation are used to create the nodes and edges of the data flow graph, and then we use add output to record a string of symbolic value in the output. So this is my part, guys. So one of my next teammate is gonna explain about the 5.2 onwards. Thank you.
Flows by identifying diffuse and information flow relations among data entities. We need to keep track of the set of definitions of each reference. Therefore, we maintain these sets via the definition store D. When a reference R with name N is found under a path constraint phi R, we look up its definitions in the set D of N and match phi R with the constructions of those definitions to retain only feasible relations. Specifically, a definition D with constraint phi D in D of N has a feasible diffuse relation with R if phi D cap phi R is satisfiable. To identify information flow relations at a variable assignment, we record the information flow from the variables on the right hand side to the one defined on the left hand side row 2. We need to keep track of the set of definitions of each reference. Therefore, we maintain the sets via the definitions store D. If a variable is defined through sequential statements, we overwrite its previous definitions with the new definitions since values from the previous definition can no longer be accessed. This paper print cross-language program slicing for dynamic web applications. We keep the values definitions of the variables independent of the branches, but combine them after executing all branches if the path constraints of both the branches of an if statement are satisfiable. We explore both branches. The function v equal v true is used to compute the constraint where a value v evaluates to true. Modifications to the definition store D where the store D take effect in the corresponding branch only. After executing the branches, we update the definition store and the value store with the combination definitions and values from the two branches with their corresponding constraints. To represent that a variable may have multiple values depending on a path constraint, we use an int 5v1 v2 value to denote a selection between value v1 if the path constraint 5 evaluates to true and v2 otherwise. We also use a it for control nodes. Similar to concrete execution, symbolic execution evaluates a function call in three steps. First, it sets up a new context call stack for the function and passes the actual parameters to the formal parameters of the function. Second, it executes the function body and records all returned values encountered when exploring different paths in the function. Third, the returned values are propagated to the call site of the function. We create a definition for each formal parameter and record the data flows from the argument of the function call to the parameter definitions in the function declaration. To track the data flow from the function to its call site, we create two special ret nodes, a retdiff node representing the return value computed inside the function and a retref node representing the propagated return value and the call site. Thank you, Professor.
Hey guys, this is Lakshmi Prasanna Singh Reddy and I'm from group 37. Today I'm gonna explain you about how to handle the special statements in a data flow analysis of a web slice. What is web slice and what are the advantages and disadvantages of using web slice? Those are all already defined by our friends, and they also told you about some part of the data flow analysis, and the remaining part I'm gonna explain it to you. And in this section, I'm going to explain you about how to handle the special statements. And under the special statement section, you will get some of a block statements like a function, and you'll also get some loop statements, and you'll also get some dynamically included files and some object files. So I'm going to explain you about each and everything in a specific section. So in first, I'm going to explain you about how to handle a block of statements. In a block of statements, the written code after executing the statement can be okay, which means that the next statement can be executed, and if it is not okay, then the control code will not going to be execute. Note that the return code can also be an iteration code. Like, so after each statement we compute the constraint under which the next statements can be executed, and we can execute them under those constraints. Like the next statement is gonna execute it under the same constraints which the above code gonna execute. So after executing the block, we update the definition store and the value store like similarly to an if statement. So but if the constraint is not satisfiable, we simply stop the execution for that block. And also in rule 7, we show that the algorithm for a block of 2 statements, like the rule for a block with more statements can be generalized from this rule. Next, I'm gonna explain you about how to handle loop statements. So in a loop, we are gonna iterating, like we are gonna repeat the code till the limit value. So for a loop, first we have to detect the data flows across different iterations. So to detect such data flows, we execute the body of a loop twice by modeling the loop as two nested if statements and applying the rule for if. So we execute the body of the loop repeatedly for 2 times, and as two if statements which is nested, and we're gonna apply the rule which we have applied for the if statement. So if the loop contains a control flow statements like break, continue, exit, like these are all the control flow statements for a loop. So if the loop contains these statements, we either abort the loop or continue the next iteration. We'll for break, return, and exit, we're gonna abort, and we are gonna continue the next iteration for continue, like for respective constraints. So these are all the control flow breaking instructions, and we're gonna continue if the control statement is continue, and we're gonna abort the loop if it is at a break, return, and exit. These are all for the how to handle loops instructions. And for the instructions for how to handle dynamically files is like, we are going, as we know, we all know that we are using a PHP program file. So a PHP program can dynamically include other files. So during symbolic execution, we execute these files if the file names can be resolved to concrete values. Since an include is an expression in PHP, we treat the return value of include similarly to the return value of a function call. Next, how to handle our objects and aliasing. When a PHP object is created, we maintain two maps from the objects fields to their values and definitions. Therefore, even if an object field is written and read by different variables, our algorithm can still recognize a diffuse relation between definition and references as illustrated before. So the same mechanism is used to handle the assignment like call by reference. Next, these are all the instructions for how to handle the multiple special statements. Next, I'm going to explain you about approximating the output and some data flows between the PHP and SQL. The output of the PHP program is usually a concatenation of multiple string values. We all know that the PHP program, like it contains some string values, and the output of a PHP program is going to be the concatenation of those multiple string values. And it's gonna print it through using an echo statement or else print statement. If it is an HTML code in the PHP program, then the inline can be used for printing the output. So to keep track of these outputs, like a concatenation of the multiple strings, we use in a concat method, which is representing the concatenation of two values, like let's say b1 and b2, which are strings. So at echo statement, or else if you are using a print statement, at a print statement, we simply record the computed value v for the output in the corresponding constraint. So the use of these concat values allow us to track symbolic output with conditional fragments precisely and compactly, which makes the subsequent variability aware, passing on the output efficiently while preserving the path constraints. So we know how to approx the output for these data flow analysis. Next, the data flow analysis between the PHP and SQL. Like for any web application, to retrieve a data from a database, one can construct SQL query. We all know that, to get a data from a database, we'll use queries to retrieve or to fetch data from an original database. And we're gonna use SQL queries by using an insert, delete, like these statements. And we can invoke a PHP functions for database queries, such as a MySQL query to retrieve data from database using a PHP function. So the returned data is stored in a record set with the rows and columns. To iterate through each row in a record set, a PHP function such as a MySQL fetch array can be used, and this array is going to iterate through each row, each record in the record set, which is a combination of multiple strings. So to access each column in a row, one can access the corresponding column of the array containing the row. Since such a array access in PHP retrieves data originating from a database, we consider it as a data flow, like a diffuse relation from SQL to PHP. In the diffuse relation, we consider the SQL query as an SQL definition and a corresponding array access as a PHP reference to an SQL entity. So, and also to detect the data flows between these, and during symbolic execution, we input the value of SQL select query, which would also contain the symbolic characters, into our variability aware SQL parser. This set of SQL definitions is propagated through MySQL fetch array function call, which is already existed in the PHP function to retrieve data. When there is an array access to such SQL data, we detect a relation between them, and we detect data flows from SQL to PHP and vice versa, like from PHP to SQL. And next, I'm going to explain you about the thin versus traditional slicing, or traditional versus thin slicing. We compute a thin slice by including all reachable nodes from a given node in a data flow graph. However, we could easily record control dependencies for traditional slicing as follows. Like at an if statement, we could additionally record the control dependencies between references on the if condition and the definitions within its branches, and we can able to extend our graph to have both control and data dependencies on entities. Like this, we can reduce the program slicing to a reachability problem on the graph. But the limitations are like our symbolic execution engine handles the common but not all PHP constants. Let's say we implement infix expressions with a concatenation operator only. For other operators, we create fresh symbolic values. For instance, we track alpha greater than 1 like a new symbol beta. Therefore, we may explore some infeasible paths. These are the traditional versus thin slicing. And thank you so much. And next, my friend's gonna continue the embedded code analysis and the cross-language cross analysis. Thank you.
Hi, this is Navya Elementally. I'm from group 37. I'm gonna explain about the embedded code analysis. So to detect data flow within embedded client code, we first phrase the output produced from the previous step with our HTML and JS variable aware phrases. So the phrases were developed using the typechef variability aware phrase framework, which enables phrasing programs with conditional paths. For example, an HTML opening tag may have two different closing tags depending on a constraint. So note that variability-aware phrasing is sound and complete with respect to the brute force phrasing all possible variants, but must faster. The phrasing results is a bare DOM representation of the embedded client code. which represents the hierarchical DOM structure of a web page. Unlike an HTML DOM, a variable DOM contains conditional nodes to indicate that certain variable DOM elements can be conditional. That is, some parts of the web page are produced under some path constraints. For example, as seen, the HTML input field update is displayed under constraint beta, and its value attribute has a symbolic value theta. In this way, the variable DOM represent all possible generated client pages with symbolic values in a single tree structure. A variable DOM also contains conditional ASCs for JS code with conditional and symbolic parts. Using the variable DOM representation of the client code, we are unable to analyze the embedded code written in HTML, JS, and build their respective data flows. Since HTML is a declarative language, we collect the definition of HTML entities. For JS code, we compute its data flows using a lightweight symbolic execution engine with an algorithm to build data flows similar to that for PHP.
Hi friends, this is Vinila Amruta Chalwadi from group 37. Now I'm going to discuss about the cross-language data flows. Basically, the data flows can exist among entities of different languages like F3 and F4. Here we're going to discuss mainly about the possible diffuse and the informational flow relations among these cross languages. First, consider the F3 cross language diffuse relations. In between HTML, JS and PHP, the PHP program can access data sent from the client page with the PHP post, get, or the request arrays. In these arrays, we have the key or the value pairs, where these keys or values are the input fields of the HTML. We call this HTML input field as the PHP references to the client-side entities. These PHP references must match the PHP page after submitting the destination to the client-side entities. Now, between SQL and PHP, we detect these relations during our symbolical execution on PHP. Between HTML and JS, the JS take the help of HTML DOM to operate on the HTML elements. Suppose if we consider the expression document to dot form one dot input one dot value, which is a JS expression, it retrieves the value from the input one of the HTML input field via form one, which is a form. We identify these JS expression as the JS reference to the HTML entities. If we write this expression on the left-hand side of the assignment, we consider it as the JS definition on the HTML entities, since they redefine the values of the corresponding HTML entities. So, similar to detecting values in the PHP, we also check the path constraints in these F3 cross values, which these client-side entities are generated to eliminate the infeasible data flows among them. Now, let us discuss about the F4 cross-language informational flow relation. In this cross-language informational flow relation, mainly we discuss about the symbolical executions on the PHP and JS. Here we keep track of the generated string values from the expressions that generates it. If these values are used in the informational flow relation in the generated code, we call them as the cross-language informational flow relation, as they are generated by using the generated code. Similarly, if we apply the same process to the predefined set of page entries to build the data flow within the individual pages, the data flows for the pages can involve the multiple files. To detect these data flows across the page entries, we detect the several types among them. Basically, the data flows act as the cookies or sessions. These are not currently supported by the present system. So the resulting data flow graph may contain identical clusters, which may not have nodes across these clusters. And the clusters all have the same code locations in the server-side program. If this is the case, then we can retrieve only one cluster and discard the others. Now we'll discuss about calling the context problem with interface data flows. In this, if a client page submits a data to the server side, the server side will call the corresponding program to handle the request. If we go through this process is almost similar to the function call. That is calling a function from a client place in which the arguments to the function call are the client's data. Although this process is similar to the function calls, but in our current implementation, we cannot execute a page entry multiple times. Therefore, this calling context problem with interface data flows results in some infeasible data flows. Thank you.
Hi guys, I'm Ramya. Now I'm going to explain about the implementation. In this implementation, we have implemented our web slice approach using an Eclipse plugin. So this web slice extends our previous symbolic execution engine and variability aware papers. So for this extension, we have used a typechefs library proportional formulas where that will be using with JavaDB backend. And for tracking part, we'll be using checking constraint. So for testing the resulting data flows and program slices composed by this web slice, we have created 100 test cases, which is a real world web application that we used in our study. So covering this study will be covering all the data types and data flows. So for data flows, which we have used with the PHP, we instrumented queries, an existing PHP interpreter, and dynamically calling actual data flow relations as a basis for our test oracles. For cross-language and cross-edge data flows, we used JavaScript and we created the test cases manually. So as we created the test cases manually, and we have created up to 20 test cases that will include interpage data flows. And among these 20 test cases, 2 of them got failed because of the web slice, as it included infeasible edge. Only test cases for other types of data will be passed except those 2. So coming to empirical study, program slicing tools are intended to help developers in various software maintenance tasks, such as identifying the impact of change. To evaluate a slice approach, one could design a user study to show that slices are very difficult to manually identify, or the developers could significantly benefit from a tool in complicated favorable cases. So, however, slicing in general has been shown to be a useful number of applications. The more interesting question is like how often we complicate these cases has occurred. So we designed a study to quantify characteristics of data flow dependencies and slices in existing web applications. Here we are interested in how many entities are embedded with PHP strings, how many data flow edges are cross language or cross strings, or how many slices are cross languages, and even web page or require investigating and embedded code fragments. So these code fragments include all properties for which no current slicing tool is available. Although such complexity measures are only proxies for such actual developer tasks. We argue like that identifying a large set of complex data flows, dependencies, or slices would demonstrate the benefit of automated slicing in dynamic web applications. So we have collected a form like 5 PHP web applications with various sizes. For each system, we automatically chose a set of page entities, PHP file that generate output containing a HTML tag, and ran a web slice on those pages to create the data flow graph for the entire system. To compute the slices, we considered each entity like a node and data flow graph and a slicing situation, and calculated the program slice for the entity. And we have also used our tool to investigate the complexity of data flow graphs in the web dynamic applications. So there are a total of let's take an example of 4,203 HTML entities are there in all the 5 systems, accounting for approximately 65% of the non-PHP entities. So there exist cases where developers would deal up to 384 HTML entities. Moreover, not all embedded entities are printed directly on echo or print statements. Only 18% are assigned to the variables prompted through the program and printed out at different location, which makes it challenging to track the data flows. This results shows that total support would be useful in those cases. Now coming to complexity of the program slices, here we can define a size of a slice as we compute the medians of the sizes and lengths of the slices and calculate the averages. So on an average, a developer would need to deal with a slice involving some entities and having a length of data flow graph. Cross-language data flows in a slice. Many of these slices are cross-language. Let's take an example as mentioned above as the 5 systems where 4,105 slices contain at least one cross-language and one data flow edge. And 35% of those slices have at least 4 cross-language data flow edges, and 9.5% may have at least 32 cross-language edges. Cross-location data flows in a slice. Many slices are also often cross-location. Let's take an example of 38% of the slices are cross files, 36% cross functions, and 13 cross string fragments.
This is Navya. I'm going to tell about the related work. There exist excellent surveys on techniques for program slicing. It provides an exhaustive survey with multiple dimensions to classify program slicing techniques. Later, it extends the dimensions. We compare web slice with the related work in the context of those dimensions. To approximate the dynamic generated client code, it proposes a flow analysis called string cat propagation to associate the variables used in print echo statements to string concatenations. They also combine with code extrusion, which uncodes the string in echo. The slice is computed from such flows. In contrast, our symbolic execution with variability-aware analysis is applicable to general cases and a wide range of PHP constraints. We also handle conditional flows and embedded SQLs or JS code. Unfortunately, according to our correspondence with the authors, their tool and data are no longer available for comparison. Web slice is close to the information flow approach. Regarding the algorithms, the information flow relations in BC are recursively computed in a syntax-directed bottom-up manner. We use symbolic execution to detect the flow relations. The dimension web slice has a different key structures. First, we consider more relations to compute the slices. For example, cross-language definition use and information flow relations. Second, regarding path awareness dimensions, unlike BC, web slice is path sensitive but unsound. So finally, the dimensions of iteration counts, we symbolically execute each loop twice to detect cyclic data flows. BC does not handle cyclic flows. There are static slicing approaches based on various static analyses. For example, incremental slicing, call mark slicing, proposition-based slicing, stop list slicing, etc. Web slice is related to PDG-based slicing. However, we must deal with flow to embedded code There are dynamic slicing approaches, including language-independent slicing, which compute a slice for one specific execution, whereas web slice produces a static slice for all possible executions. Web slice produce a static differs from the family of conditional program slicing, constraint slicing, and pre or post conditional slicing, where an initial state is defined via conditions. There exists much research on exploring flows among web pages for testing or code comparison. However, they do not build cross-language, cross-state slices as in web slice. There exist string analysis approaches for web programs and software security. They can be used to extract embedded code in our analysis. The extract database interaction, whereas web slice extract only database columns, names, and slice through PHP. In our prior work, we designed a simpler symbolic execution output. Subsequently, we developed to analyze both PHP and client-side code to detect embedded references. Later, we built HTML code. We build data flows and slice upon them as explained. Our symbolic execution on JS is similar but simpler than the one for PHP. Thank you.
Hello, I'm Prithvi. As we are doing cross-language program slicing for dynamic web applications, I'm here to conclude things. On a brief note, I'll take you once again into the paper. Program slicing is an important and useful technique in software engineering applications. For example, it is a useful tool to assist developers in understanding the impact of their changes for activities such as programming or bug fixing. Like when a developer modifies some part of the program, performing slicing from the change point can reveal the potentiality affected parts of a change. Various slicing techniques have been developed for traditional software systems. Program slicing for web applications is challenging due to dynamic feature. Well, the brief abstract of the paper is, during the software maintenance, program slicing is an useful technique to assist developers in understanding the impact of their changes, while different program slicing techniques have been proposed for the traditional software system. Program slicing for dynamic web applications is challenging since the client-side code is generated from the server-side code, and data entities are referenced across different languages and are often embedded in string literals in the server-side program. To address those challenges, we introduced web slice, an approach to compute program slices across different languages for web applications. We firstly identified data flow dependencies among data entities for PHP code based on symbolic execution. We also compute SQL queries and a conditional DOM that represents client code variations and construct the data flows for embedded languages SQL, HTML, and JavaScript. Next, we connect the data flows across the different languages and across PHP pages. Finally, we compute a program slice for a given entity based on the established data flows. Running web slice on 5 real-world open source PHP systems, we found that out of 40,670 program slices, 10% cross languages, 38% cross files, and 13% cross string fragments, demonstrating the potential benefit of tool support for cross-language program slicing in dynamic web application. Well, to conclude, we tackled the challenges of computing program slices with multiple languages for dynamic web applications. We introduced web slice, an approach that combines symbolic execution, variability-aware parsing, and data flow analysis on embedded code to identify PHP data entities as well as embedded SQL, HTML, JS entities and recognize the data flows among them with one language and across different languages. In our empirical study on 5 real-world PHP systems, we found many non-trivial cross-language across string program slices. In such cases, cross-language program slicing tool support such as WebSlice could be useful in assisting the web developers with software maintenance tasks. Thank you.